Hello friends, this video on alcohol, phenol and ether part 24 is brought to you by examfear.com. No more fear from exam. Let's see the reaction with zinc dust. So it'll go for reduction. At high temperature I have this phenol, I have OH, this bond will break. Zinc at high temperature, I'll get benzene ring back. NZL. This is the reaction that will happen with zinc dust. Now let's see the oxidation reaction. See, oxidation reaction, I don't have the mechanism as such. This is my phenol. It reacts with Na2Cr2O7 and sulfuric acid. It will give benzoquinone. Sorry, this won't be a stable one. This is what it will get. Yeah, this is benzoquinone. The next is ammonia reaction. See, for the ammonia, the reaction is pretty simple. I have this OH, I have NH3, I add this ZnCl2 and some heat. What I get is NH2 and some water, and this is called aniline. Right, so you have to give a high temperature, maybe 575 Kelvin, and very high pressure. Correct. This is ammonia, NH3. Let's take one more important reaction linked to ammonia. So I have this OH here, phenol, and let's react to CH2N2. It's plus and this is minus. So what will happen is this will take out this OH from here, right? This bond will break, and what you get is O minus and CH3N2 plus. This N2 will easily go off, right? This nitrogen gas goes off. So what you get with this is my O minus and CH3 plus. Now there will be a direct reaction between them. Actually, it should be in this side. So you get OCH3. We'll take one more reaction. We'll take acid chloride reaction. So here we have this phenol, OH, and will react with C2H5 COCl. So here if you see, chlorine is electron high electronegativity, it will get slightly negative charge, slightly positive charge. Here also we'll see this bond will break. Actually, I'll show you why. This, what you get is O CO C2H5 and you get HCl back. This is phenyl ethanoate. This is a nucleophilic reaction. Let's see the reaction mechanism of this. See, I have this, let's assume OH here, O with lone pair, and it reacts with C2H5 COCl. This is slightly positive, slightly negative, right? This is slightly positive, so this lone pair of this oxygen will try to attack on this, right? And with that it will form, it will have to kick out something. Correct. So it will kick out, or let me just first add them. So what happens is, actually it will kick out this bond will break, right? This bond will break and you'll get Cl minus out, and if you see this O now, it has H and it has CO C2H5. Correct. So this bond broke, so it got a positive charge here, right? And this went here, so it will get negative. So oxygen will get a positive charge. Correct? Why? Because oxygen, from oxygen electrons are going into positive charge here, this gets negative charge here. But this bond broke, this negative, this positive. This positive and negative will get cancelled out. So oxygen will get a positive charge here. But that is unstable. So hydrogen will say, okay, I'll go off from here. So this will become O, CO, C2H5. Correct? And H plus will come out. Why? Because oxygen positive charge is not stable. Oxygen is electronegative element. It can't hold positive charge. So hydrogen will say, okay, I'll come out. So hydrogen will come out. We have seen this kind of reaction so many times where we have positive charge on oxygen, then hydrogen comes out to make this compound neutral. Well, now we'll see the reaction with haloalkanes. So haloalkanes, I have my phenol, and let's suppose I have sodium hydroxide and CH3I. So when this reaction happens, what happens is you get OCH3 plus NaI and H2O. This is anisole. Right? We talked about similar reaction just now. I'll show you similar reaction. We have just talked about CH2 and 2. So this OH, when it reacts with NaOH, it gives ONA. Right? O minus Na plus. Correct? This is we know. Now on this, when you react CH3I, this is electronegativity, so it's slightly negative, slightly positive. This will attack this guy. Correct? It's called Williamson's ether synthesis. So with this, you get something like this, OCH3 plus NaI. And this is my anisole. This is my SN2 reaction. Correct? Because this is my the next reaction is dehydrogenation reaction. So here what happens is I have my phenol, I don't have the reaction mechanism for this, and I just add hydrogens to it. So what happens is this aromaticity is broken and you get cyclohexanol. Obviously you need some nickel catalyst for this. So we have seen the hydrogenation. This is not dehydrogenation, it's hydrogenation actually. Hydrogenation. So we are adding hydrogens, yeah. So we have seen the nickel catalyst in the alkene chapter when I have some alkene and then you add as a nickel catalyst, I have some hydrogen atoms, and it gets added and becomes alkanes. I think similar concept is here. The next thing we'll learn is the acid character of phenols. So as we've discussed this earlier also, I have this phenol OH, right? So this oxygen is giving electrons, right, to the whole ring. So since it is giving electrons to the whole ring, it has less electron density. Correct? Less electron density. Since it has less electron density, it has to get electron more because its job is to give electrons to the aromatic ring because of the lone pairs, right? But since it also needs electron, so from whom oxygen can get electron? From hydrogen. From hydrogen also it will produce the electron. It will get slightly positive charge, slightly negative charge. Correct? Please understand this. See, oxygen has lone pair. Its job is to give electron to this ring. But this guy also wants, oxygen also wants electron. Since it's giving electron to the ring, it gets electron from hydrogen now. And hydrogen develops partial positive charge. And since hydrogen has partial positive charge, it can give H+. So it is acidic. It is more acidic than alcohol. So let's compare alcohol and phenol. Phenol is weak acid. Alcohol is very, very weak acid. In fact, it's weak base also. It's amphoteric. So if you see this alcohol, as I told, Oxygen attracts electron from R, any alkyl group in the aliphatic chain. So it has high electron density. On density. So it is happy with by extracting electron from this R. So it is not bothering this hydrogen, right? It is not having positive charge here. But if you see this alkyl group, right, oxygen gives electron to this alkyl group, to this phenyl group. Now since this is giving electron to this phenyl group, it needs electrons. It's electronegative, but it's high electronegative element. It's happy to have electrons around it. So it will take electrons from hydrogen, it will have partial charge, this will have partial negative charge. So since this hydrogen has partial positive charge, it is acidic. Here it is not partial positive. Why? Because oxygen is happy with the electrons it gets from alkyl group. So it is very weak. Phenol is it's very weak acid. Sometimes it is base also. Correct. Also, this has partial double bond character. If you see, draw the resonance, you'll see that somewhere you'll see that it has partial double bond character, right? This bond has partial double bond character, so it is difficult to break this bond, but this bond it can break. So it is all the more acidic because this bond is difficult to break, right? Difficult to break, but this bond is easy to break. Why? Because this bond has OC bond has got partial double bond character, and that's why the CO bond length is also less due to resonance. Correct? And the dipole moment of alcohol, if you see, is more than phenol. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.